right, number 6. A piece of modern art was originally purchased for $3,500 in 2001. Okay, so that tells me that's my initial amount. Okay. When the artist was just out of school and was valued at $75,000 in 2011, when the artist was featured on an exhibit in Tokyo. What rate of interest compounded continuously? Okay, so that tells me I'm doing an E to the RT. What rate of interest compounded continually did this investment earn? So they didn't give me the rate. I'm supposed to find that. They did give me the time. So it was between 2001 and 2011. So that's 10 years. And it went from 3,500 to, whoa, 75,000. That's pretty cool. So I'm solving for R. So I would divide by 3,500. Let's just do that. Oh, and I put my comma in the wrong spot. 3,500. Okay, so then I can reduce that slightly. That's 750 over 35 equals e to the 10r. I need to find r, so I'll take the natural log of both sides. Natural log of e to a power will just simplify to just be the power. And I'll come up here and finish. So I have the natural log of 750 over 35 equals 10r. So I'll divide by 10. And r equals natural log of 750 over 35 all over 10. So I'm going to bet this is a pretty good number. Natural log of 750 divided by 35 and divided by 10. Okay, so when I put this in, I get 0.3, roughly 0.31. But if I want to think of this like as a percentage, that's 31%. That's pretty good. So it does say what rate of interest, so I would probably leave it like that. Well, let's do number 7. Find the present value of $500,000 to be received in 20 years if money can be invested at 9% compounded continuously. So, okay. So this is worded kind of funny. You may have noticed that I did not read this beforehand, and I also didn't write it. But what this is saying is somebody gives you a gift of $500,000, and then you can't touch it for 20 years, and it's compounded continuously. So it's invested at 9%, so 0.09, and then it sticks there for 20 years. So let's put that into a calculator. This is a very nice number. So that would be, let's see, there's a lot of digits here. So that's pretty nice. 20 years. It's a good gift, I'd say. So the wording in this problem that's weird for me is that it says find the present value of 500,000 that's going to be received in 20 years. So it's like kind of a weird way of saying you'll get the money, but you can't touch it for 20 years. Let's do number 8. How much should you invest now to have 100,000 in 40 years? Okay, so I want 100,000. It's not how much I have, but what I'd like to have. I don't know how much I'm going to start with because that's what I'm supposed to find out. And this time I'm compounding monthly. 2%, 0.02, monthly m equals 12. And then I want to check back in 40 years. So this is a little bit more difficult. So let's simplify as much as we can. So I have 100,000 equals P. And then this part inside the parentheses is just a fraction, or, you know, something, a decimal would work also. So we'll simplify that. So this is 1.001, let's go 67. And then 12 times 40 is 480. The nice part here is that this is just something you can put into a calculator. So we'll do that. Okay, so putting that into a calculator, oops. So 100,000 equals P times, let's see, putting into a calculator, I got 2.2276. Then solving for P is pretty easy. I'm just going to divide by 2.2276. All right, if I do that, I get that P is approximately 44,891. Let's see. And let's see, sorry, my calculator's doing a weird thing. 0.36. Okay, so you would need to invest about $45,000 so that became 100,000 in 40 years. That might be the last one in this section. Yep. Okay, if there are any questions, post them to the discussion board.